Hi everyone, today we are going to learn about piecewise functions. Before we get started, we're going to do a quick warm-up to refresh our brains on what a function actually is. So for this warm-up, I would like you to please pause the video and jot down a few things that you remember about functions. When you have an answer, please go ahead and restart the video and we will see how well you did. Okay, so hopefully you wrote down a couple of things that you remember about functions, or at least remembered that you studied linear functions before, or drew at least a picture of what a function actually is. So there's a few things that I need you guys to know. Let's say that you did draw a linear function somewhere onto your paper. Why is this a function? Well, there's a few things. Every input has exactly one output, and that is the first thing. Every input has exactly one output in a linear function, as well as any other function that you can actually plot onto a graph. So that's what I'm going to write. Every input has exactly one output. And what is an input and output? Well, an input represents your x values, or your domain values. And outputs, those are your y values, or your range values. So every input has to have exactly one output. So if we were to look at a graph and determine whether or not that graph is actually a function, we would have to do a little test. And that little test is called the vertical line test. And what the vertical line test says is that if you were to take a vertical line and pass over at any point throughout an actual function on a graph, it will only cross one point at a time. If you have a graph where more than one point is crossed by a vertical line, it's not considered a function. And an example of not a function would be something like a circle. The graph of a circle is not a function, and that's because if I were to draw a vertical line going through it, it crosses more than one point. In this case, it would cross 2 points. So even though maybe there might be a section of the circle where it would only be crossed by 1 point, if there is anywhere on that graph that can be crossed by more than 1 point with a vertical line, this is not considered a function. So those are the two main things that you need to know about functions, because today we're going to be learning about a brand new function, and that's called a piecewise function. And what a piecewise function looks like is it looks like pieces of different functions put together. And what I'm showing you here is actually our graph for the first example. In our first example, you're going to see that we have pieces of linear functions all put together to create a new function. So why is this graph a function? Well, if you notice, we have open circles and we have closed circles. And in our last chapter, we learned that open circles means that those points are not included in the solution. So they're actually just starting points that are not included. But you'll also see on this graph closed circles. And just like we learned in the last chapter, that closed circle means that it is included. So at these two locations that I'm identifying, you can see that only 1 point is actually closed. Therefore, it satisfies the condition, or it satisfies the definition of functions, that every input has exactly one output. I find this to be very sarcastic, but that's what math is. It's a little sarcastic at times, and this is where we're heading. So we're going to use our prior knowledge about linear functions to another level, or we're going to take that to another level today and actually graph some of these piecewise functions. And that is what our first blank is. It says piecewise functions. A piecewise function is defined by at least 2 equations, each of which applies to a different part of the function's domain. And your domain is your x values. So for example, the absolute value function y is equal to the absolute value of x can be defined actually by 2 separate equations. The first one is y equals x. And we use y equals x if x is greater than or equal to 0. So if I were to just sketch y equals x just for the values for x is greater than or equal to 0, I would be drawing a ray. That ray would be pointing to the right, and it would be pointing up to indicate that we have ourselves a positive slope. I would not include the other part or the other piece of our linear function. I'd only draw a portion of it. The other equation is y equals negative x, and that represents the left side of the graph. And we only use y equals negative x if x is less than 0. So if I were to graph y is equal to negative x just for less than 0, I would actually have an open circle on top of a closed circle, and I would draw a ray pointing to the left. And together, this open circle on top of a closed circle and our two rays coming off of each end, or coming off of our vertex, creates an absolute value function. So we're going to be exploring this a little bit more and later into our lesson. So first of all, it's important for us to know how to evaluate a piecewise function. So because we're going to be graphing two different pieces or multiple pieces of linear functions for different domains, it's important that we understand how we can come up with our values, how to evaluate, how to let x equal something, and know which piece that x value is going to go into. So the first example says, evaluate the function g of x is equal to 2x minus 1, and we only use the piece 2x minus 1 if x is less than or equal to 1, and 3x plus 1 if x is greater than 1. So it just depends on what our x value is that's given to us to determine which piece we're going to use. Remember that g of x is just function notation. It simply means a very fancy y. All right, so I'm going to let x equal 1. So I need to figure out where would x equal 1 fit in the domain. Well, we have x is less than or equal to 1 in our first piece. And since 1 is less than or equal to itself, we're going to plug 1 into the 2x minus 1 piece. So I'm going to write 2 times 1 minus 1. 2 times 1 minus 1, that is equal to 2 minus 1, which is 1. And if we were to plot this on a graph, we would plot the ordered pair 1, 1. Our input was 1, our output was 1, and that is our ordered pair. Let's go ahead and look at letter B. For letter B, we have g of 5, and 5 is located in the x position. So what that means is that we are going to let x equal 5. So if x is equal to 5, 5 is greater than 1, so it fits with the second piece of 3x plus 1. So I'm going to substitute 5 into that piece. So we have 3 times 5 plus 1. 3 times 5 is 15, and 15 plus 1 is equal to 16. And if we were to plot this on a graph, we would plot the ordered pair 5, 16. All right, so now let's go ahead and graph these actual piecewise functions. So we have example number 1, graphing piecewise functions. So what I would recommend that you do is I would recommend that you recognize that these pieces are going to be parts of linear functions. And linear functions are lines. And we learned in geometry last year that there are pieces of lines like that, we learned last year in geometry that if we're going to discuss pieces of lines, there are two different types of pieces. There are rays and there are segments. And the graph that we are going to be drawing, we're going to be drawing rays and segments depending on our domain. So how do you know if you're going to have a ray or a segment? It depends on your domain. In this case, the first piece that we have is negative 3/2 x minus 1, and that happens if x is less than negative 2. X is less than negative 2. If we were to graph x is less than negative 2 on a number line, we would have an open circle at negative 2, and we would be shading all of the values of x less than negative 2. This shape is a ray. In our next piece, we have x plus 1 happens if Negative 2 is less than or equal to x, which is less than or equal to 1. If we were to graph the domain on a number line, negative 2 would have a closed circle, 1 would have a closed circle, and we would be shading all of the values in between. We have 2 endpoints in this case, and this is an example of a segment. And finally, we have f of x is equal to 3 if x is greater than 1. So if we were to graph x is greater than 1 on a number line, we would have an open circle and we would be shading to the right. And once again, this shape is a ray. So it's very important for you to identify what this piecewise function is going to look like before you even draw it. So now what I would recommend that you do is work with each piece individually. So I'm going to label each piece 1, 2, and 3. So working with piece number 1, I have negative 3 halves x minus 1, and that happens if x is less than negative 2. And I'm going to create a table. Just like we did when we were in Algebra 1, we would create tables, and I'm going to call this table x, y, and type. We're going to let x equal certain numbers, and then we're going to come up with our output. And then that's going to represent the ordered pairs that we're going to plot onto our graph. So how do you pick out which values of x to choose? We'll always select the value of x that's given to you. So I'm going to automatically choose the number negative 2. And I'm going to plug negative 2 into my piece. So I have negative 3 halves times negative 2 minus 1. Negative 3 halves times negative 2, that number is a positive 3. And 3 minus 1 is equal to 2. So this is the number 1 right here. 3 minus 1 is equal to 2. So at 2, negative 2, what type am I going to have? Well, because negative 2 would have an open circle on our ray, I'm going to have an open circle onto my graph. And that's where I'm going to start. I'm going to plot negative 2, 2 with an open circle. All right, so in order for us to draw a ray, we need 2 points. So my next x value is going to be an x value that is smaller than negative 2. Now, because our slope is a fraction, I would recommend choosing a value that's smaller than negative 2, that's a multiple of our denominator, like the number negative 4. That way you end up with nicer numbers to work with. You're more than welcome to work with negative 3, but you're going to end up with a fraction. So this is just a trick. So I'm going to write negative 3 halves times negative 4 minus 1. So negative 3 halves minus 4, that is going to be equal to 6. And 6 minus 1 is equal to 5. Now because negative 4 is part of our shaded region in our number line, we're going to actually have a closed circle. So when I plot negative 4, 5, I'm going to make that a normal point. I have 2 points. I now have enough information for me to draw a ray. So if you have a straight edge at home or the side of a calculator, please use that straight edge in order to draw your pieces. And here's my first piece. This is my first ray. All right, now we're on to the second piece. The second piece is x plus 1, and that happens if negative 2 is less than or equal to x, which is less than or equal to 1. I'm going to create the same exact table, x, y, and type. And the nice thing about the segments is that they already tell you the 2 numbers to actually use. I'm going to use negative 2, and I'm going to use the number 1. So I'm going to let x equal negative 2, and negative 2 plus 1 is equal to negative 1. So my output is negative 1, and my type, because this is an equal to, I would have a closed circle on my number line. So I'm going to plot a closed circle at negative 2, negative 1. So here's negative 2, negative 1. Next, I'm going to let x equal 1, and I'm going to plug 1 into my piece. 1 plus 1 equals 2. So at the ordered pair 1, 2, I'm also going to have a closed circle because we have an equal to symbol. Less than or equal to, 1 would have a closed circle. So at the ordered pair 1, 2, I'm going to plot a closed circle. This is a segment, so I'm only going to connect these 2 points with just a little line that connect, and I'm not going to draw any arrows going through it. It's a segment, a starting point and an ending point. Next, my third piece is 3, and that happens if x is greater than 1. And this one's kind of confusing. What does the number 3 mean? Well, let's change f of x to just y. This means y equals 3. And y equals 3 are your Hoy situations. And remember that Hoy means horizontal line, 0 is your slope, y equals a number. So we're going to simply draw a horizontal line. And what's nice about just drawing a horizontal line is we automatically know what our output is going to be. It's going to be the number 3. So what we need to figure out is what x values to choose. We always choose the number that's given to us. So I'm going to select 1. And if x is equal to 1, y is equal to 3, and my type in this case is going to be an open circle. And the reason why it's going to be an open circle is because we have a greater than symbol, not a greater than or equal to. So we will have an open circle at 1, 3. Going over to 1, up to 3, I'm going to draw an open circle. Next, I need to pick a number that's greater than 1, like the number 2, and my output is automatically going to be 3. And because I personally picked the number 2, that's a part of the shaded region, this is going to be a closed circle. So I'm going to go over to 2, 3. I'm going to plot a closed circle. And remember that this is an array. This is always starting with the number that's given to us with an arrow pointing at the end. All right, let's go ahead and do letter B. For letter B, we have 3 pieces again. Always label those, 1, 2, and 3. So working with our first piece, we have f of x is equal to 2, and that happens if x is greater than 3. So I'm going to write 2, and that happens if x is greater than 3. I'm going to create my table, x, y, and type. And what's nice about this problem is that they give us a Hoy right away. This is a y equals 2. Horizontal line, 0 is your slope, y equals a number. And I'm going to automatically use the number that's given to me, which is the number 3. And my output's going to be the number 2. And my type in this case is going to be open. And why is it open? Well, because 3 is not included in this number line. I would anticipate, once again, having array, a segment, and array for this piecewise function. And if it's helpful for you to draw out the number line, draw out the number line. For 3, we're talking about all values of x greater than 3. 3 is going to have an open circle, and we're shading all of the values that are to the right of 3. Our segment in this case, we have 0 is less than x, which is less than or equal to 3. And if we were to graph this, at 0 we'd have an open circle, at 3 we'd have a closed circle, and this would be a segment in between 0 and 3. And finally, our array, we have x is less than or equal to 0. So at 0, I'm going to have a closed circle, and we're going to shade all of the values of x smaller, or to the left of 0. So I need to select a value of x that is bigger than 3 in order for me to continue. But before I do that, I'm going to graph 3, 2 with an open circle. So I'm going to go over to 3 and up to 2, and I'm going to plot an open circle. Next, I'm going to pick a number bigger than 3, like the number 4, and my output is automatically going to be the number 2. And I'm going to plot a closed circle. Why is it closed? Because 4 is part of my solution set. 4 is part of the shaded region. So I'm going to plot 4, 2, and I'm going to draw a ray, starting at the point 3, 2, and going through 4, 2. Cool, I'm done with that piece. Now I'm on to the next piece. We have negative x plus 1, and that happens if 0 is less than x, which is less than or equal to 3. And one of the nice things about segments is that, well, you already know which numbers to choose. So I have x, y, and type. So I'm going to let x equal 0, and I'm going to plug 0 into my function. I have negative 0 plus 1, and that is equal to the number 1. Now, because I have a less than symbol, and it's not an equal to symbol, I'm going to have an open circle. So I'm going to go to where 0, 1 is, and I'm going to plot an open circle. Next, I'm going to choose the number 3. And I'm going to plug 3 into my function. So this is going to be negative 3 plus 1, which is negative 2. And this will be a closed circle. And the reason why it's going to be a closed circle is because 3 is part of the solution set. We have a closed circle if we were to graph this on a number line. So I'm going to go to where 3, negative 2 is, and I'm going to plot a closed circle. Now remember that this is a segment, and all you need in order to draw a segment is just 2 points. We have our 2 points. We're going to connect them with a little line. Step 3, or piece number 3. We have the function is going to be equal to 4, and that happens if x is less than or equal to 0. Once again, this is a Hoy situation. Y equals 4. Horizontal line, 0 is your slope, y equals a number. And I'm going to create, once again, the x, y, and type table. And I'm going to select the number that's given to me, which is the number 0. And my output is automatically going to be the number 4. And because I have an equal to symbol, my type is going to be a closed circle. So I'm going to go to where 0, 4 is, and I'm going to plot a closed circle. Next, I'm going to pick a number that is less than or equal to 0, like the number negative 1, and my output is going to be 4. And it's also going to have a closed circle because negative 1 is part of the solution set. So I'm going to go to where negative 1, 4 is, and I'm going to plot that point. And remember that this is an array. It always starts with the number that's given to you and goes through the number that you personally selected. Now look at these 2 graphs. You can tell that you did them correctly if, where there's the overlap, you see that one circle is open and the other is closed. Same with down here. One is open and the other is closed. One is open and the other is closed. If you see 2 closed points, that tells you did something incorrectly, because every input needs exactly 1 output that actually works. So just please be careful. Please go ahead and try letter C on your own. Pause the video, and when you have an answer, please go ahead and restart the video, and we will see how well you did. All right, so for letter C, we have ourselves 2 pieces. So I'm going to label each piece 1 and 2. And I have 3x minus 1. That happens if x is greater than or equal to 1. And based on what I can see here, I'm going to have 2 rays. If I were to look at my number lines and plot 1, the top one is going to have a closed circle, and it's going to represent all values of x that are greater than 1. And I'm going to have a ray. And once again, we have x is less than 1. So at the number 1, I'm going to have an open circle pointing to the left. So that's something that I should see. 2 rays. So I'm going to automatically select the number 1 that's given to me. And when I do that, I have 3 times 1 minus 1, which is 3 minus 1, which is 2. So my first ordered pair is 1, 2. And because 1 is included, I'm going to have a closed circle. So I'm going to plot 1, 2. So going over to 1 up to 2, here is my first point. Next, I'm going to select a number that is bigger than 1, like the number 2. So I'm going to write 3 times 2 minus 1. That is equal to 6 minus 1, which is 5. 2, 5. And because I personally selected 2 and it's part of the solution set, I'm going to have a closed point, and I'm going to plot 2, 5. And this is a ray, so I'm going to start at the point that's given to me, and it's going to go through 2, 5. That is my first piece. My second piece is negative 3x plus 5, and that happens if x is less than 1. So creating my table again, x, y, and type, I'm going to personally select the number 1, and I'm going to write I'm going to select number 1 because it is given to me. And I have negative 3 times 1 plus 5. So that is equal to negative 3 plus 5, which is 2. So I have 1, 2, and because this is not an equal to, I'm going to have an open circle. But at 1, 2, I already have a point right there. So it's kind of need to put like an open circle right there just to establish that there's an open circle on top of a closed circle. And then from there, I'm going to pick a value of x that is smaller than 1, like 0. And I'm going to write negative 3 times 0 plus 5, and that's going to be equal to the number 5. At 0, 5, I'm going to have a closed circle, and that's because 0 is part of my solution set. So I'm going to go to 0, 5 and plot a point. This is a ray, so I'm going to start at my open circle and go through the point that I just plotted, go through 0, 5, and I'm going to draw another ray. So now the question is, what is the name of this graph? Well, this is an absolute value function. It's in the shape of a V. And we can graph absolute value functions by making piecewise functions. So the skill that I'm going to assess you on is how well you can create a piecewise function or rewrite an absolute value function as a piecewise function using the graph. So we already know how to graph these functions based on our experience from the last chapter. So that's exactly what I want you to do first. So step number 1 is I want you to graph. And that's going to be based on your vertex, where you identify your vertex. And in this case, our vertex is going to be located at the opposite of what we see inside, which is a negative 2, and exactly what we see on the outside. And in this case, we have a plus 0. So at y equals the absolute value of x plus 2, there's a plus 0 on the outside, and that's going to represent our k value. So I'm going to plot my vertex, which is located at negative 2, 0. And then I'm going to apply the slope of the right-hand side. And in this case, the slope of the right-hand side is the number 1. So I'm going to rise 1 and run 1. And I'm going to do that for a few points. And whatever I do to one side, I'm going to do to the other. And I'm going to draw my absolute value. I recommend coming up with a few points on each side, just so that you have your V shape that looks nice, and it'll also help you in future steps. Cool, so this is graphing my piecewise function. The next thing I want you to do is I want you to identify your domain pieces. So that's going to be step number 2, identify your domain pieces. So what are your domain pieces going to be? Well, domain is based on your x value. And our x value in this case, if we were to look at letter C, our vertex is located at 1, 2. And our domain is going to be based on the vertex x. We had all of our x values to the left and all of our x values to the right were addressed in our pieces. So this 1 actually came from the vertex x, the x part of our vertex. So our focus is going to actually be on negative 2. So our domain pieces are going to be where x is greater than or equal to negative 2 and x is less than negative 2. It doesn't matter which one has the equal to symbol as long as one has an equal to symbol and the other one doesn't. So my domain pieces are going to be to represent the right-hand side, and in this case the right-hand side of the graph represents all of the values of x that are going to be greater than or equal to negative 2, and the left-hand side of the graph, which is all of the values of x that are going to be less than negative 2. And I got negative 2 based on the x part of my vertex because that's where my domain is. Step number 3. Now that you have your domain pieces, we need to write an equation for both pieces, the equation of a line for each piece. Because remember that each ray comes from a line. So the next step, like I said, we're going to write equations, or write an equation for each ray. You can work with the right-hand side first and then the left-hand side, just as long as you are organized. So I'm going to start with the right-hand side. For the right-hand side, let's identify the slope. We already know that we're rising 1 and running 1. So my slope in this case is equal to 1. My b value, well, my b value in this case looks like it's going to be 2. So b is equal to 2. So for the right-hand side, the equation is going to be x plus 2. Cool. Let's talk about the left-hand side. So the left-hand side of the graph, okay, I'm going down 1 into the right 1. So it looks like my slope is going to be -1. And my b value, well, I'm not exactly sure what that is. So one approach is that you can keep going and see if you can come up with where it's going to cross. So if I were to keep going, and notice I'm using pencil, I'm just going down 1 to the right 1, down 1 to the right 1. If I were to continue with this line, it would eventually cross the y-axis at 0, -2. So my b value in this case is going to be -2. Remember, it's not part of our graph, so you have to make sure that you're very careful and have a nice eraser. But our equation is going to be -x minus 2. Cool, so now I have an equation for each piece. This is y equals and this is y equals. Step number 4 is you need to write a piecewise function. So what does that look like? Well, a piecewise function has the f of x or y equals on the outside. So that's what I'm going to write. I'm going to write f of x, or if it starts with y, you can write y equals. So maybe I'll just stay consistent and I'll just write y equals. And then we have a brace. So we have like a little squiggly mark, a brace that goes around it. I'm going to represent my right-hand side. The right-hand side of the graph has the function x plus 2. And you have to write the word if. We only use this piece if x is greater than or equal to -2. And then the left-hand side of the graph, that equation was -x minus 2. And that happens if x is less than -2. And there's your piecewise function. Let's go ahead and do letter B together just to make sure we're all on the same page. Number 1, you need to graph your function. So my vertex in this case is located at -1, -3, because it's the opposite of what I see on the inside and exactly what I see on the outside. And I'm going to plot -1, -3. And then my a value in this case is -2. So working with my a value, this is the slope of the right-hand side. I'm going to go down 2 and to the right 1. And I'm going to come up with a reflection point on the other side, going down 2 and to the left 1. And here's my absolute value. Great. Step number 2 is to identify our domain pieces. Our domain pieces are based on the vertex x. So in this case, my x part of my vertex is -1. So the right-hand side of my graph is going to be where x is greater than or equal to -1, and the left-hand side of my graph is x is less than -1. Step number 3, we need to write an equation. So we need to write an equation for each piece, or for each ray. So the right-hand side, let's look at it. The right-hand side, it looks like we're going down 2 and to the right 1, so our slope in this case is -2, and our y-intercept is located at 1, 2, 3, 4, 5. So my b value is 5. So my equation is going to be -2x plus 5. Let's look at the left-hand side of the graph. And you can write it equal to y, that's fine. The left-hand side of the graph, it looks like we're rising 2 and running 1 is our slope. So I'm rising 2 and running 1. So m equals 2. And I'm going to use that slope to see if I can see where it crosses. So rising 2 and running 1, cool. right there would be my anticipated b value, and that is located where b is equal to -1. I'm going to erase it because it's not part of my function. And I find that y is, my equation is 2x minus 1 is equal to y. So now step number 4 is where you actually write your piecewise function. Putting everything together, we're going to write our piecewise function. And since this case we're starting off with a y equals equation, I'm just going to write y equals with a brace, and the right-hand side of my graph is going to be -2x plus 5, and that happens if x is greater than or equal to -1. And the left-hand side of my graph, I'm going to write 2x minus 1 happens if x is less than -1. This represents the right-hand side and the left-hand side. And that is the end of today's lesson. If you have any questions over anything I just talked about, please feel free to have a conversation with me or email me. Otherwise, I hope you have a wonderful day.